In two dimensions, and this is really a review as well from the grade 11 course, but it's important enough and it's a big topic in this unit. So acceleration, it's not just a change of speed, it could also mean a change in direction. So if you had a car driving at 40 meters per second in one direction and it hits a curve, it doesn't change its speed but ends up driving 40 meters per second in a different direction, there's still an acceleration and there's still a calculation to be done. So we use the basic formula, but it's kind of like you have to do it, depending on how you approach it. Either you do it, use this formula, and you do this vector subtraction right here, v2 minus v1. This vector subtraction has to be done either using x and y components or done using sines and cosines. Okay? The strategy then is you do the vector subtraction, and then the time is a scalar, right? It's a scalar quantity. So you can it's a divide, right? You do the vector subtraction, and then you just take your number result, sort of the magnitude of your answer, nothing to do with the direction, and you divide that by the scalar time. And that's the strategy we take, okay? And that would be it. So that's just what I have written down here. So when you do your dividing, you don't divide anything related to the direction by time, you just take the magnitude of v2 minus v1 and divide it by. Okay, so let's just see an example of what I'm talking about. Here we have a car starting at 45 meters per second, west 20 degrees north. It ends up still at 45 meters per second, but different direction, and we're given a time. So let's find the acceleration. And like I say, the strategy is 1, using this sines and cosines or components, and then take your answer and divide it by 20. Okay? I chose these 45 and 45 to make it very clear that if you made the common mistake of just going v2 minus v1, 45 minus 45, like without considering the directions, you'll get 0, and that doesn't make sense. You're definitely accelerating. Okay? So I'm choosing sines and cosines because I want to do fewer steps. Okay? So here's my givens. V2 is here, V1 is here. Remember, when you use sines and cosines, you have to find negative v1 because we're going to do, you're doing a vector add, but you're adding the negative, right? So I take the negative v1, east 20 degrees south. Okay, so remember, when you do the negative, you just change the direction. That's all you have to do. And I start the drawing. So here's my v2, right? Here's my negative v1, east 20 degrees south. So it's, this angle in here will end up being 20 degrees. Okay, and I just said here, let's see, because I don't really want to deal with, write this out 1,000 times. So I just say C is that. Okay, again, if I'm going quick, please just pause. And so here's my picture. Here's my V2. Here's my negative V1. The magnitudes are just 45. You don't change the sign. It's just magnitudes. And here's my final vector then, starting where at, basically from the very start to the very finish. And that's hard to see that, but that is the end of my vector. And just angle-wise, remember this was 30 degrees south of west, so 30 degrees down here. And my negative V1 was 20 degrees south of east. Okay? So the first thing I do is apply the cosine law, figure out, all the angles, see how this 30 equals this right here, because of the Z law, right across here. Okay? So that dot and that dot are equal, so both 30, so that makes this whole angle 50 degrees. And I'm going to want to find this angle here eventually, but first I'm going to find C. So it's going to be related to the cos of the angle across from it, which is the cos 50. Work that out and get 38 meters per second. Over here, I have my sine law because I want to find this angle in here. Right? So the sine of this angle over 45 will be the sine of the 50 over my 38 that I calculated. Okay? Using the sine law, rearrange, you get 65 degrees. Okay, not going through the details on the sine law anymore. I think you can probably figure that all out. So now, I know this whole bit is 65 degrees. So if I just try to blue up this part here. So I know that, again, looking at just this part in here, it's what this is supposed to be a little bit bigger of, that if this whole thing is 65 degrees, the little bit that the green is east of the south is 5 degrees, right? Because this is 65. I know this is 60 because these two have to add up to 90 to fit in here. Okay? And so, therefore, my final vector is 38 meters per second, 5 degrees east of south. Okay? And I'm sure I'll put a check mark on that. It's a good answer. Let's just see. Actually, that's not my final answer, I suppose, but does that make sense? Does it make sense that the acceleration and the change in velocity is east of south? It starts moving, the initial speed was, let's see, what's the initial speed? West and north, and it ends up south of west. So it's definitely accelerating in the south direction, and it's, if you think about it, it ends up moving a little bit more east than it started. So it does make sense. But let's keep going with the solution to get acceleration. This part's easy though. You just take the 38, divide it by the time, which was 20 degrees, right? And I end up with 1.9, which is a good number, right? We said between minus 10 and 10, and the direction does not change. And that's my final answer. Okay, so that's acceleration in 2D.